All right, so we're back at it again. We're going to see if we can simplify this expression by using trig identities. First thing, remember I said whenever you have more than one fraction, you want to get a least common denominator. In this case, my least common denominator is just multiplying those two denominators. And then I'm going to multiply those terms by cosine and these terms by sine to get my least common denominator. So cosine times 1, cosine. Cosine times sine, well, that's just sine theta cosine theta, plus sine cotangent theta. Now I'm on the other side. And then minus sine cosine theta. So nicely you can see those cancel. So I'm left with cosine theta plus sine theta cotangent theta all over sine theta cosine theta. Please do not cancel this cosine with that cosine. Please, fractions don't work that way, remember? So I look at this other piece here and I say, well, what if I change that into my cosine over sine? Then what would happen, because these are being multiplied, that would cancel and I would just end up with the cosine on the left, and the only thing that's left on this side is a cosine. And sine theta cosine theta. Now up top, this becomes 2 cosine theta, cosine plus cosine. And then same thing, haven't touched the bottom the whole way. Now you can cancel. And so I get my final answer of 2 over sine theta. All right, so lots of steps, lots of canceling, but just, trying to figure out a way to simplify this expression. Okay, this next one, probably when you first look at it, it's like, I don't know what to do. However, and you need to be careful here because remember the formula is sine squared theta plus cosine squared theta equals 1. And I don't know what good it would do to turn this into a negative cosine squared, right? Because you'd move it to the other side because there's no cosines on the bottom. But that might have been your first thought. But do you remember the difference of squares where I can actually factor this top out and it becomes sine theta plus 1 times sine theta minus 1. Remember that? Remember that? And then the bottom, notice both of these have a tangent. So I'm going to factor out the tangent. And then that leaves sine theta minus, well, I factored out tangent, so minus 1. So as you can see, that cancels. And I end up with this as my final answer. So like I said, at first it may have seemed a little daunting, but once you figured out this step to be able to factor those, then not as horribly bad. All right, let's see what's up next for bid. All right, as soon as I see things with negative angles, I'm going to go through all my steps of trying to simplify because I'm trying to show this left side looks like the right side. Well, one thing you need to be sure you realize is the way this sine squared of negative theta is written, you could write that like this. And that's important because then I'm going to tell you, well, remember that sine is odd, so the negative comes outside. But then I'm going to say, well, notice when you square something, it becomes positive. So I kind of needed you to understand how you could rewrite that square. And so up top here then becomes a positive sine squared theta. The cosine, remember, just stays, the angle goes positive. Then on the bottom, this one's not squared, so I actually need to bring out my negative. So negative sine theta, and then minus cosine theta. All right, well, immediately up top, I see the difference of squares. So I'm going to factor this into sine theta plus cosine theta, and sine theta minus cosine theta. And then on the bottom, you need to be careful of which one of these are going to cancel. So what I'm going to do, I'm going to factor out a negative sign. So if I factor out a negative sign, the sine becomes positive and the cosine becomes positive. So actually, that's the one that factors out. And so that just leaves me with a minus sine theta minus cosine theta. Or now if you want to distribute the negative back in, would be positive cosine theta minus sine theta. And as you see so nicely, that gives me that back.